All right, let's go ahead and jump right into it. Lab number 4. So, with that being said, I ran that chunk, and now you can see my data. Great, fantastic. I'm gonna do something eventually in this video. Yeah, with the VS and AM. I think just VS. So let's see. So here we're doing simple linear regression, and what we're going to look at is how horsepower predicts miles per gallon. Okay. So let's do that. So let's go ahead and say our y variable. All our y variables should be. I'm just going to do a little bit of a control F. Okay, and then do y variable. At first I was thinking I'm not going to teach the students how to do this, but this is taking me a lot of time. So I'm just going to do replace. Okay, good. Thank you for your expertise. Then X. Then put this as HP. Okay. Replace. Okay. And it's nice for you to even do that, just so that even if you do the control F, that's fine. As long as you know that this is finding the mean of miles per gallon, this is finding the standard deviation for miles per gallon, the min and the max for our explanatory variable, and then correlation between our explanatory variable and our response. So when we run this, you can feel some type of satisfaction that you did this, okay? Our correlation is negative 0.77. You see the means for both, standard deviations, the min and max for our explanatory variable, okay? We can now look at this visualization, okay? Oh, look at that visualization. Doesn't look nice. Okay, that you have the regression line, you have the points. Bam, good job. And then finally, you have your model. Okay, so this is where I want to emphasize a couple things. So we know for a fact that our slope estimate for horsepower is negative, yes. And this p-value, you know that you would reject the claim that there's no linear relationship between horsepower and miles per gallon. We will reject that. However, I want to emphasize this r squared is 0.6024. One would argue that value is pretty high. But can we make it higher? Can we add another variable to our model to explain more variability? And the answer to that is yes. So what we'll do is we will do some cool things using some using some data science. We're gonna change go to model 2, and this is what we'll do. We'll call this the dummy variable model. Okay, more on that in class. Let me do what I did before. Interesting. Control F. And this will be horsepower, replace. I can do all at the same time, but whatever. Horsepower. Whoop. Good job. Now y variable. A y variable is going to be miles per gallon. If you make the mistake, it'll tell you. Oh, it's going to tell you. It's very, very sensitive. R is so sensitive. Okay, good. All right. So with that being said, we can now do a couple things. So I don't want to take, because it's not the point of the class, but this is going to allow me to, what I'm going to do is add another variable, VS. I believe VS is transmission. We're good on time, so let's look at this. Let's go to empty cars. VS, I always forget this. VS is engine, okay? So if it's 1, it's V-shaped, and if it's 0, it's, if it's 1, it's straight. If it's 0, it's V-shaped. So with that being said, I can now actually group the variables for 2 lines, okay? So there's a regression line that I'm going to create that where it has straight for the straight engines. Don't know what that was. Okay, and then there's a regression line for the V-shaped. All right, and so let me go ahead and create this visualization. There's a whole bunch of non-necessary code. It is necessary, but yeah, it's code. What's annoying about the dummy variable model is that it assumes that both lines have the same slope but different y-intercepts, which is kind of fine. You can see that there is some kind of difference, but it doesn't distinctly show you where the actual regression line should stop. Low key or high key, the actual blue line should only be up here and should probably stop around here. And the pink line should be from here to over here. You're going to see that in the interaction variable model. But I didn't know how to fix it, so I kept going with my life. So this is the actual visualization. Okay, this is the visualization for a dummy variable model. Now let's see if we increase the amount of variability that's being explained. Sorry, the proportion of variability that's being explained. So remember, the simple linear regression model had 60% of the variability being explained. Let's see what happens here. 62% of the variability. Sorry, it actually went down because 59% of the variability is explained. Because again, we're using this one because it's multiple linear regression. The dummy variable model sometimes is good, sometimes it's not. This is the case where it's not. I think in class the notes it's not the greatest either. But it gives us the leeway, it gives us the guidance, it gives us a step to the interaction variable model where we have two different y-intercepts as well as two different slopes. So let's see what that looks like. This upcoming code is the same. I'm going to do a little bit of a game of copy and paste. Copy and paste. Boom, 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 boom. Look at it. I could just skip this part, but I'm just going to be consistent. I don't need this. Boom. And it should work. Bam. All right. So then from here, what I'm going to do is make this HP. I'm going to manually do it this time. Okay. You see the code's a lot simpler for the visualization. Okay. This is miles per gallon. Now look at this. It's going to do everything for us. It's going to stop. The blue line is going to stop where we don't have data. And the pink line is going to stop as well. And you can see the slopes and the y-intercepts are different. Okay. The slopes and the y-intercepts are different. So with that being the case, when I actually run my analysis, the last step, which is so exciting that I'm finally here, 7 minutes in, we have miles per gallon. And then we have horsepower according to the different engine types. And we're going to notice that there's going to be a difference. It's going to be significant, right? In terms of the difference in slopes, okay, as well as the difference in y-intercepts. If you're watching this video before one of the days in class, it may not make sense, but this is nice. The interaction variable model works pretty well. Look at it. It jumped from 60. It went from 60% for simple linear regression. Then it went to 59% for dummy variable model. And then for the interaction variable model, look at that, 67%. Let's look at the standard deviation residuals. 3.428. 3.8. Okay, that's not the greatest. Okay. And then from here, it's 3.86. So the best is the interaction variable model. Thank you for watching. Have a great day.